last lesson on waves, and this is an optional lesson. It's about redshift and blue shift, and we learn about this, or this is very interesting because it will tell us whether the light that we get from distant stars or galaxies enables us to know whether the star or galaxy is approaching us or moving away from us. Now, the reason is stars and galaxies are all made up, there is light being emitted that is from different elements, and you know how every element has its own signature spectral lines. And so, if you look at the light from a star, analyze it using a spectroscope, and when you see the lines and you compare it with the lines of the same sample of the element in the laboratory, you can tell whether the star is approaching or receding. If the observed wavelength is shorter, that means it has undergone what we call a blue shift, because the spectral lines would move closer to the blue end of the spectrum. Okay, so this is your laboratory sample. These are the spectral lines of the element. When you compare the same sort of spectral lines from an approaching star, you will see that every line, it's the same, but they've all shifted towards the blue end. In the same way, if the star or galaxy is moving away, then the apparent wavelength will be longer. Hence, it will be at a lower frequency. So there will be a shift in the spectral lines towards the red end of the spectrum, which is the longer end of the spectrum, and this is called a redshift. So here's your laboratory sample, and if the star is moving away, everything would have undergone a red shift. So this red is further away compared to that.